In this video, we will consider the difference between independent and pairwise independent. So let me remind you, what does it mean independent? We introduced definition for arbitrary n number of events. Let's consider, for simplicity, only 3 events, A, B, and C. Independent means that the probability of intersection is the product of all 3 probabilities. So this means independent. Sometimes people may confuse this with pairwise independent. What does it mean, pairwise independent? This means that A and B are independent, B and C, A and C. And sometimes people use this to prove that 3 events are independent. It's not in fact correct. We cannot conclude from this, if we check these 3, we cannot conclude that these 3 events are independent. And in fact, it can be proved that if ABC are independent, so in this sense, then they are pairwise independent. So from this thing, we may conclude this. But inverse, in general, is not true. So we cannot make conclusion backward. So this is not correct. Okay, and the following example shows you that indeed it's not correct. Assume that we have 4 flags: red, yellow, green, and a flag which contains all 3 colors. And we choose one flag randomly and consider the following events. Event R, our chosen flag, contains red color. Event yellow, the same, the flag contains yellow color. And event G is the flag contains green color. And let's study these 3 events as A, B, and C and check if they are independent and pairwise independent. So we need, in fact, the probability of R. The flag contains red color. The 2 flags out of 4 contain red color. So this is 2 out of 4, which is 1/2. Similarly, all these probabilities are also 1/2. Next, let's look at the event, for example, R intersection, red intersection with yellow. Which outcomes this event contain? Of course, the outcomes of this flag, right? The red contain the 2 flags, red and 3-colored flag, and yellow contains yellow and 3-colored flag. So this intersection contains only one event, which means that the probability is 1/4. Similarly, all the other R intersection with green, the same as probability of R of green intersected with yellow. They all have just one outcome of 3, the flag of 3 colors, and the probability is 1/4. And in fact, you can check that, for example, PR intersection with yellow is 1/4. This is 1/2 times 1/2, so this is product of probabilities. So R and yellow are independent events. So this pair is a pair of independent events. And similarly, R and green and yellow and green are independent. So we may conclude that these three are yellow and green are pairwise independent. Right? What about just independence? We need probability of intersection of all these three. Probability of R intersection with yellow intersection with green. And again, the common intersection of these three events only one, this flag, right? So the probability is 1/4. But if we calculate the probability, the product of probabilities, this will be 1/2 times 1/2 times 1/2, which is 1/8. They are not the same. So they are pairwise independent, but not independent. So there is example of pairwise independent events which are not independent. So you cannot check independence just checking pairwise independent. It doesn't work.